Mobility. Mobility of electrons or holes or charge carriers like positive ions or negative ions. It is the ease of movement of such type of charge carriers like electrons or holes or ions. This is represented by mu. Now let me talk about the electron mobility. How easily an electron can move through a conductor or a semiconductor. In the case of semiconductor, it can be in terms of electron or holes, positive holes. It is also defined as the magnitude of drift velocity per unit electric field. It is given by the equation mu is equal to the modulus of, because we confine to the magnitude. So modulus of drift velocity divided by electric field, where Vd is constant. When Vd is constant, then mu is inversely proportional to the electric field. That is, mobility is inversely proportional to electric field. As we already discussed, it is given by the equation mu is equal to modulus of Vd, the drift velocity, divided by electric field. We know already Vd is nothing but Q into electric field E into tau, that is the relaxation time of electrons, divided by m. So we can replace this and get another equation like mu is equal to Qj divided by m. Now let me discuss about the SI unit of this mobility of electrons. SI unit of mu is equal to meter square per volt, that is volt inverse second inverse. Dimension formula is m power minus 1 L power 0 T squared ampere. Let us discuss how we are able to get this SI unit and dimensional formula. We already know V is equal to mu is equal to Vd divided by modulus of Vd divided by electric field. We know that is potential is nothing but the product of electric field and dl. That is, it is the potential means the work done in moving the charge. So in this case, V is equal to electric field in displacement, that is dl. Therefore, E can be defined as V by dl. So V is nothing but volt and dl, the differential element of distance displacement, that is, we can put length element or displacement. So the unit for electric field is volt per meter, that is volt divided by meter. Volt is nothing but the potential. So it can be interpreted in terms of work done by charge, that is in coulomb, and therefore W by Q. So this is another famous equation. And work done, that is given in joule. And what about Q? That is given in ampere second, because we know already Q is equal to IT. So I ampere, T second, ampere second. Okay. And joule is nothing but Newton meter. Newton is the unit of force. So force Newton, that is equal to MA. So we can replace this by, that is MA means kg meter per second square into meter, and that gives the watt, that is joule. So kg meter square per second square. Okay, right. Now we can replace this. Effectively we can use these equations in terms of, that is, electric field. So SI unit of this one is meter squared. We can put volt inverse second inverse. Now I am going to replace all these things. Now mu is equal to meter squared V inverse second inverse. Meter squared is equal to, we already know it is joule per ampere second, so I have replaced this. So meter squared kg m squared s power minus 2 divided by ampere second. So whole power minus 1 into second power minus 1. Therefore meter squared kg inverse, then meter inverse meter power minus 2. So meter power minus 2, meter power 2 can be cancelled, and you have got s cube into s power minus 1, so it becomes s squared. So put s squared and per ampere. Now kg inverse per ampere and second squared. In fact, when you take this ampere, okay, ampere, when it goes up it becomes per ampere, and once again minus or minus plus, you can put plus here. So it is plus 1 ampere simply, or you can write m power 0 L, m power minus 1 L power 0 T squared ampere. So this is the dimensional formula of mobility. Are you able to understand? Okay, and you make this small correction, that is this ampere becomes ampere power minus 1, minus of minus plus 1 here. Okay, so this is plus 1, and finally we get the dimensional formula also, right?